Alright folks, let's pick up where we left off here with number 15, finding a quotient. This is extremely similar to the last problem we had here back on number 8, where we were dividing each one of those three things on top by x. So we're going to be after the same thing here. They just wrote it differently. Really, you could think of this whole thing here as being divided by 5y and just not even having that right there. So we divide each one of those by 5y. Remember to reduce the power as we do so. So 5 divided by 5 is 1, y to the third and y to the first. That makes y to the second. Negative 10 divided by 5, just divide that out, you get negative 2. Y squared divided by y to the first, drop it down a power. The reason why we're dropping them all down by 1 is because we're subtracting 1 from each one of these up here. 25 divided by 5 would give us a 5. Notice what happens here. Y to the first, y to the first, y to the 0. In other words, write down y 0 times, so it's not there anymore. So there's that answer. Okay, so now as to for this factoring problem here, what they really wanted you to do, and you tell me which way you're going to prefer to do it here, is factoring out the greatest common factor out of all those, which would be 5 and then x to the third. Biggest thing we can take out of all of those. Then what you'd have to do is divide each one of those by 5x to the third, giving us with x squared minus 9x. Divide that by 5, we'd have positive 20 all by itself there, and then 0. Then what we'd have to do is keep that 5x cubed and factor even further. Two numbers that multiply to give you positive 20 and add together to give you negative 9. Be minus 5 and a minus 4. And then what you'd have to do is set each one of these three terms equal to 0 and solve and find the zeros that way. So 1, 0, that one right there in blue, opposite game. So x would be equal to 4. Opposite game with the red one there, 5. Opposite game here in the green one, well, 0 is going to make that 0. So you can come up with your solutions there. Got another way. Let's type the function into the graphing calculator. How I got here is I hit the y equals button. So let's type this in here, 5x to the 5th, jump down, minus 45x to the 4th, jump back down, then plus 100 x cubed. Now hit the graph button. What the graph just did is it crossed over where the solutions are, the zeros, remember? So hit second graph and then look at the table and spot your zeros here. There's a 0 right here at 0, a 0 at 4, and a 0 at 5. Doesn't match the answers that we have right here, 4, 5, and 0. There we go. So I prefer the graphing calculator way of doing it personally, just typing the function in, graphing it, going to the table, and spotting the zeros that way. Alright, next problem here. Let's take this function up here, stretch it vertically by a factor of 6, and shift it through to the left also. When it says factor in a lot of cases you usually use that with multiplication, don't you? So what they want you to do is take this function, which was originally 2x cubed plus 4, and stretch it by a factor of 6. Means take that whole thing and multiply it by 6. To do that, we have to use the distributive property. So what we'll end up here with is 12x cubed plus 6 times 4 is 24. Next, we need to shift this thing 3 to the left. This is where your opposite game with parentheses comes into play. Shifting it to the left 3 is like saying x plus 3. So what you're going to do is you're going to replace and move this x plus 3 right in there for x's place. Get that x out of here, and now we're going to replace it. So now we have 12 times x plus 3 cubed still plus 24. Okay, so the order needs to take place like this no matter what the numbers are. Do the stretch first by doing the distributive property, and then to shift it left or right, make sure that you're playing the opposite game. So just to make sure we're on the same page, what if they wanted to move it 3 to the right? Well, then the opposite game here would tell us to use x minus 3. And so then down here, we'd have to rewrite that stuff in there, and then we'd have x minus 3 in there. These problems should be pretty easy. A lot of students do well with this one. Two things you have to do here. First, figure out if it's odd or even in degree, and then we got to figure out if that leading coefficient is positive or negative. In order to figure out if it's odd or even, if the arrows go, and let's put those arrows in there, there's one, there's the other, if the arrows go in opposite directions, it is odd. So do these arrows go in opposite directions? Yes. Yes, they do. So this would be an odd function. If the arrows go in the same direction, it's even. S-A-M-E-E-V-E-N. Same letters, I guess. That would be a way we can remember it. Same with odd and opposite. Now, positive and negative, all you have to focus on here to figure out if it's positive or negative is focus on the right arrow. If it goes up, it's a positive direction. Things are looking up. So this particular function here is odd and positive. If the right arrow went down, it would be negative. So when we look at this problem here, notice that the degree, because the arrows both go down, it's got to be even because they're going in the same direction. Secondly, notice that the right arrow goes down. So the leading coefficient had to be negative. Y varies inversely as x. Y equals 8, x equals 2. Write and graph the inverse variation function. Inverse variation function. Remember what that one was? Y equals fraction k over x. That was inverse variation. We'll go through all of them on the next problem, which is direct variation. But inverse variation is always y equals k divided by x. So what they want you to do here is to take y, which is 8, substitute. Second, take the 2 and substitute that in there for x. So we have k over 2. Now solve for k. To solve for k, what we have to do up here is multiply both sides by 2. So that makes k equal to 16. So now to write the function, y equals 16 over x. In other words, we write a function with x and y still put in place, but then we put the k value that we just found in here. Now the key to graphing it, just making those the hyperbola here, is think about if you were to make a table out of this thing. It makes sense to me to only use numbers that are divisible by that you can divide evenly into 16, like say 16 for instance. If x was 16, y is 1, but if you look here, x is 16, y is 1, doesn't fit, right? We can go down a notch here. Maybe if we used 8, isn't it 8 and 2? 16 divided by 8 would be 2. So hey, this one fits. Go 8 to the right, 2 up, there's a point. What I'd like you to notice about these two numbers, these pairs of numbers here, 16, 1, 8, and 2, it's just two numbers that multiply to give you k up there, 16. So what's another pair? How about 4 and 4? Right there. And then can't we swap the 8 and the 2 around, call it 2 and 8? Sure can. There we go. So we have one branch right there, and it's not going to touch the x-axis or the y-axis. To pick up the second branch, realize what happens if we make all these negative, 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 negative. It's going to make these ones negative, 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 just because we're doing division here. So we'd have more branches here at negative 8, negative 2, negative 4, negative 4, and negative 2, negative 8. So there's our hyperbola. Alright, final question for this video, and we'll do the other ones on another video. Let's determine if this set is direct variation, inverse variation, or neither. We just did inverse variation, right? That was y equals k divided by x. Direct variation is y equals k times x. So we got to figure out which one this set of data fits. So you can use the x and the y's, plug them in, and figure out what k is. And if you get the same k, then that's the variation that we're using. So if we look at this one right here, 2 and 504, if I'm checking direct variation here, that means that 504 would need to be equal to k times 2. Well, solving for k here, if we divide both sides by 2, that would give us 252. Moving on, what if the y was 336? Equal to k times x, in this case is 3. If we divide both sides by 3, what's that one going to be? Well, that one would be 112. You see why we can stop right now? The whole point here is to figure out if it's direct or inverse, and the key is seeing if those k values are the same. We don't even need to check the third one. They're not going to be the same. So this thing is definitely not going to be direct variation. So let's start over and see if it's inverse variation. Put in the 504, k over 2. To solve for k, we got to multiply both sides by 2. So 504 times 2, and that be 1008. Repeat, 336 equals k divided by 3. Multiply both sides by 3 now. Hey, that's good, 1008. Maybe we're on to something here. Alright, so let's not assume anything here. We got to check the third one. Because notice it worked for that one, worked for that one. Now we just need to see if it works for the third one. Do you notice what we're doing here to get k every single time? Notice we're taking x and multiplying it by y. X times y. So look at that. 4 times 252. $1,008 again. So I think we got it. So this thing here was definitely inverse variation.